Alright, so hello again. So what we're going to do now is I can calculate an element's atomic mass that is found on the periodic table. So what I want you to write down first is this definition again for atomic mass. It is the weighted average mass of all the natural occurring isotopes of an element. Right, now there are two key points here. First of all, weighted average, and I'm going to show you what that is, and of the natural occurring isotopes. So if it doesn't naturally occur, they can only make it artificially, it doesn't count. So first thing I want to focus on though is this weighted average. And we're going to do today an example with hydrogen. There are three different isotopes of hydrogen. There's hydrogen that just has one proton, and this is its relative mass, 1.0078 AMUs. There's hydrogen with one proton and one neutron with this relative mass. And then something that's very, very rare is hydrogen that has two neutrons and one proton with this relative mass. What I want to show you first is how you would not calculate it. The key thing here, weighted average. If you were to do a regular average of these three numbers here, and to save us a bunch of calculations, I'm going to keep it simple. I'm going to just round it to 1 AMU plus 2 AMU plus 3 AMU. What you would normally do to take the average of this, add all these together, and then divide it by how many things you're adding together, which is three numbers. So 1 plus 2 plus 3 divided by 3. That comes out to 2 atomic mass units. But the thing is, I'm looking right here at the number on the periodic table for hydrogen's atomic mass. The number is 1.00794. So this isn't how you calculate a weighted average. Let me show you how to do that.
Okay, so let's use this worksheet, and I'm going to show you how to calculate the atomic mass of hydrogen that you find on the periodic table. Alright, so here's the thing. We got our three isotopes of hydrogen over here. We have the relative masses that if you needed to do just a standard average, right here. Now, the thing that about a weighted average is this. You need to multiply these by a percent. And the percent that we multiply these by is what we call the natural percent abundance. This column right here. And that's just how much of each one of these isotopes is naturally found in nature. Right? So two things that you have to do to have this weighted average for atomic mass. The relative mass here, and you multiply that by a natural percent abundance, how much there is of it in nature. Right? And once you have that, it's just two easy steps. Step one is you multiply the relative mass by the percent abundance for each isotope. I'm going to add one thing here because the number one mistake will be is I want you to make sure move decimal 2 places to the left. To get this percent, we had to move it from a decimal and times it by 100. It moves it 2 places to the right. So for each one of these, we're going to move the decimal 2 places to the left, and that's what we're going to multiply our number by. So our first isotope here is hydrogen 1. It has an atomic mass of 1.0078 atomic mass units. And that gets multiplied by the 0.99985. We move that decimal 2 places to the left. And when you multiply those two numbers together, you come up with a number of 1.0076 atomic mass units. Our next isotope, hydrogen-2, has a relative mass of 2.0141 atomic mass units. That gets multiplied by its percent abundance. Moving the decimal 2 places to the left, it's 0.00015. If you plug that into your calculator, you're going to get 0.0003 AMU. Now here's the thing with our last isotope of hydrogen, hydrogen-3, there isn't very much of it found in nature, a very, very tiny percent. So to be honest with you, we're not even going to worry about that in our calculations. It won't have any effect whatsoever. So all you do now, you don't have to divide anything together for a weighted average. To get this weighted average, you just add together your two pieces. And when you add these two numbers together over here on the left, you get 1.0079 AMU. And if you take a moment to grab your periodic table and you take a look at the atomic mass for hydrogen that's on that periodic table, you'll see that it does come out to that number right there. Now what I want you to do to practice is I want you to do from your honors textbook, page 87, number 19. And what you're going to be practicing there is you're going to calculate the atomic mass of argon. And there are 3 isotopes of argon that you will end up multiplying the relative mass times the percent abundance of each, and then you'll add all 3 of your numbers together. Okay. Watch this video as many times as you need to help you work through that problem on page 87, number 19. And good luck.